Okay, I'm going to try to make this one shorter than the last one. So we're going to be talking about specifically in a graph, if a graph is going to pass the test as to whether or not it's a function or not. And so I'm going to teach you specifically about something called the vertical line test, and that's going to help you be able to use a quick method that will help you figure out whether or not it passes the vertical line test or not and is a function. Okay, so this is actually taken from your textbook. Again, if some of you had your textbook home because you had been preparing for your test, then it's in 5.5. So the vertical line test is a way for us to be able to tell on a graph if it is a function or not. So if every x has only one y. So we've looked at, a table of values. We've looked at arrow diagrams. We've looked at ordered pairs. And now we're going to look at a graph or a couple different kinds of graphs to be able to decide whether or not it actually represents a function or not. So here's our actual definition. I'm going to get you to get this copy down if you would. A graph represents a function when no 2 points on the graph line, on the graph lie on the same vertical line. So what you do, here's the method. You're going to place a ruler vertically on a graph. So let me just draw a graph to show you. So let's say we've got, a graph like this one. And perhaps it goes like this. And maybe this is a graph that represents kind of the rise of people getting COVID-19, or what we're trying to avoid people getting COVID-19. So if I take my straight edge, and I can use they said a ruler, but you can use anything that's straight. So a lot of people just pick the pencil right out of their hand. And I start to run this across like so. If at no time, which this one doesn't, at no time does my pencil touch the graph line in any more than one place, then it's good to go. It is an actual function. So this is, so let's say place straight edge, pencil or ruler on a graph, then slide the ruler across the graph from left to right. Wouldn't really matter if it was left to right, but that's just a good tool. Here's the question. Here's what you're looking for. If one edge of the ruler intersects the graph at no more than 1 point, the graph represents a function. Okay? Let me slide that up for you a little bit. It's getting messy, isn't it, guys? Sorry about that. So is this a function? Yes, this is a function. It passes the vertical line test. It only touches in one place at one time. Let's try one that I know. Maybe this one is, so this one right here, this kind of data, because the line continues, this is called continuous. You remember that from grade 9? That's a continuous graph. You could stop anywhere along the line and this information would be true. Okay, but I'm going to do one now that is going to actually represent a discrete data. So let's say I've got a point here and 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 a point there and there and there and there. Okay? So again, this is always my X, this is my Y every time we're looking at graphs. So I'm going to take my straight edge and I'm going to line it up vertically and I'm going to start moving from left to right. And what I'm looking for is at any point does my straight edge, my vertical straight edge, touch this graph in more than one place? And look right here. That is hitting my line, my vertical line, in 3 different places. 1, 2, 3. And that's because this X, let's say this is the number 4, has an association with this Y, a 3, a 4, and a 5, right? Do you see that? So that means that, if I had ordered pairs, it would look like this. My 4 has a 3, my 4 has a 4, and my 4 has a 5. So just trying to help you see the connection between ordered pairs and how you know in an ordered pair that it's not going to be a function because the X repeated. Well, right here, the X has 3 different Y's. And that's why we use this vertical line test to help us figure out if in fact it is a function. So this one is not a function. Okay, let's try another one. Okay, so let's call this one, this is called a parabola. And you're going to see this when some of you are planning on taking, not a very symmetrical parabola, but anyway. This is from a quadratic function. So when you get to grade 11 foundations, you'll see lots of these. But let's just take our pencil or our ruler or our pen or whatever and start from the left-hand side of the graph, this being my graph line right here. Start running across. Does it at any place touch 2 spots on my pen, on my vertical line? No, it doesn't. So this is actually a function. Yes, it's a function. Okay. What if we try one like this? It's a weird looking graph, isn't it? It's a circle. But watch. It doesn't pass. Like, look at how it touches here and here. As you go across the circle, it's touching in 2 places all the time, there and there. Like, it's not passing, so this is not a function. So this is actually an example. The data here is continuous as well. This is continuous. This is continuous. And this one right here is actually discrete data. So we'll talk more about that later too. But so what you're noticing is that this particular, like, let's look at this X right here. So let's say X right here is a 1. That means that the Y it's associated with is a 4, but it's also associated with a -3, right? So it has a Y as a 4 and a Y as a -3. So if I were to write that as ordered pairs, it would look like this: 1 and 4 and 1 and -3. Well, that's what makes it not a function. Whereas over here, every single X has only one Y. Every single X has only one Y. Okay? I'm going to show you another example of how to do that with some discrete data. Okay, so if you're looking at this first graph, height against shoe size, what you're going to notice is that if you took your pencil and you put it vertically and started to run it across the page, where would it be that an X had 2 different Y's? Well, when you have your pencil vertically up and down on the 7, a shoe size at 7 is only for a height of 170 centimeters. 7.5 is about 100, let's say 168 centimeters. But look what happens when you get to 8.5. Now you have 170 and 175 centimeters that are associated with the shoe size 8.5. Look at size 9. Size 9 has 3 different associations, like let's say 167, 175, and 178 centimeters. So 3 different associations. So does that fit our rule, our definition of what a function is? No, because every x can only have one y. And so when you look at this one and you're trying to use what's called the vertical line test, you run your pencil across the page, keeping your pencil straight up and down vertically, you'll notice that if your pencil touches 2 different dots at the exact same time, it has just failed the vertical line test. Therefore, it's not a function. Now look at the next graph, world population. When I think about world population in 1950, it's saying that it's about 2.5 billion people. In 1960, it's about 3 billion people. 1970, about 3.75 billion people. Look at 1995, I guess that'd be 2000, wouldn't it? It's just over 6 billion. Doesn't that alarm you? How much that has gone up. So just to the point of a vertical line test, though, if we ran our pencil from the left side of the paper over to the right, you're noticing that every x, where are your x's? Don't forget the x's are the years, the x's are the shoe size. The x has only one y. So that's what you have to continue to ask yourself is, does every x have only one y? Does it pass, if we're looking at a graph, does it pass the vertical line test? If it does pass, that means your pencil, your ruler, whatever it is you're using that's up and down, only touches one dot at one time. And it doesn't always have to be dots either. We'll look at some graphs that aren't just dots. Okay, so just the final kind of piece, just to look at a couple more that are not actually discrete. These 3 graphs all represent continuous data because they're lines that are connected. That's kind of how I remember continuous versus discrete. Discrete means that there's dots that are not connected. Continuous means that they are connected. So when I look at this first one, if I were to use the vertical line test, you'll notice that the x at the 0 has 2 different y associations. It's at the 1 and at the 5. So if I put my pencil on there and started running it across, it would not pass. I mean, it would not pass in other places as well, but that's definitely one place. And then if I look at B, I took my pencil and I started running it from left to right. On this graph, it would pass because it would only touch in one place at one time. And then finally in C, when I look at that one and I start running my pencil across, I see that it actually would pass, even though it looks a little bit weird there in places, but really it would only touch in one place at one time. And that's really all it comes down to is, will it touch in more than one place at one time? If it does touch in 2 places, then it's not going to be a function. So I'm going to wrap it up here with just a little closing comment. Well, guys, a YouTube sensation I am not, but I am making an effort here to try to help you out and posting these videos. I hope they're helpful. Anyway, so just closing up, I hope that you can start to see the difference between a function and just a general relation. Remember, all functions are relations. They're an association between an x and a y, basically. The elements of a domain and the elements of a range, but there are some specific ones that are called functions. And so that's what we've been looking at in the last 2 lessons, is the difference between or how to determine if it's a function within an arrow diagram, within a table of values, within ordered pairs, a word association. And today I showed you how to be able to determine if it is a function in a graph. So I'm going to also add in there your RF2 targets. If you want to send them to me, probably honestly the best way for this to be kind of like stress less is for you just to wait until I post the answer key. I feel like the answer key gives me another opportunity to show you how I'm coming up with these answers and kind of walk you through the answers. So I think that's probably the best way to do this, especially because there is no grade. So I think that's probably how I'm going to go about doing this, and it's kind of changing as I need to change things, but hopefully that works for you. And so I'm just gonna, I think I'll do it that way. If you have any other questions, feel free to add those to the team chat and let me know, and I can add those to a warm-up of sorts at the beginning of my next lesson. It seems like it's working out to be about one of these a week. Does that sound about right for everyone? Doing about one video a week, and then with the work on top of it. I know that probably by the time you watch these two videos today, you have nearly an hour into that, and so and then by the time you do some work, you're supposed to be doing 2.5 hours a day for 5 days a week. So I think that's probably plenty for math, and then you also have your English and your other subjects as well. So I think that's probably plenty, and that gets us going for the rest of this week. All right, have a great week.